Hey everyone! This is the fourth part of the series on configuring the ANJ-6200-48PL. And this is the longest video in the series, because the F2 menu is the largest. 28 items, and all of them are about the battery. Why so many? Because the battery is the most expensive part of your system. And how correctly it is configured determines not only how it performs today, but also how many years it will last overall. The wrong charging algorithm leads to premature degradation that you won't even notice right away, but you'll feel it in a year or two, when the battery capacity suddenly turns out to be much lower than expected. So let's approach this video seriously. The structure will be as follows: first, the most important items: battery type, charge source, thresholds and currents. Then timers, equalization, lithium management. And at the end, a summary table of recommendations for the two most common battery types. If you haven't watched the previous videos, I recommend starting from the first one. The third video about the F1 menu is especially important, where we covered the system operating modes. Some F2 items are directly linked to whichever mode you selected there. Alright, let's go. F201, battery type. This is the first and most important item in the entire F2 menu. This is where you tell the inverter which battery it's working with. And everything depends on this choice: what the charging voltage will be, what algorithm, what protection thresholds. Never select the type randomly or leave it as is. This is not one of those items where you can make a mistake and nothing will happen. A mistake here means either an undercharged battery or an overcharged one. And both options shorten service life. Let's go through each option. AGM, these are sealed lead-acid batteries with absorbed electrolyte. This is the most common type for home systems. The full charge voltage for 48-volt batteries is 56.4 volts. The algorithm is configured for this voltage when AGM is selected. This is the default value. Flooded, these are wet cell batteries with liquid electrolyte. They are cheaper but require maintenance. You need to check the electrolyte level and top up with distilled water. The charge voltage is higher, 58.4 volts. If you charge flooded batteries at the AGM voltage, they will chronically remain undercharged. USE, these are user-defined settings. You select this type when you want to manually set all charge parameters. For example, if you have non-standard batteries or lithium without BMS communication. When USE is active, items F203, F204, and F207 become available. They are locked for other types. Li2, this mode is for Pylontech batteries in the US2000 series and compatible models. With this selection, the inverter establishes communication via RS485 and receives all parameters from the battery's own BMS, voltage, current, temperature, SOC. You don't configure anything manually, the battery itself tells the inverter what it needs. Li1 and Li3, these are other lithium systems with their respective communication protocols. It depends on your battery manufacturer. Check the documentation or confirm with the manufacturer. An important warning: if you have AGM and you select flooded, the battery will be systematically overcharged. Gas release, heating, premature degradation. If it's the other way around, flooded set to AGM, chronic undercharging and sulfation. Both options multiply the reduction in service life. F202, charge source priority. Here you decide a simple question: where to charge the battery from? From solar, from the grid, or from both simultaneously? Option 1, solar first. Solar takes priority. The grid for charging is only connected if there is no solar at all. This is the logical choice for those who want to maximize free solar energy and minimize grid consumption. Option 2, Solar and Utility. From solar and grid simultaneously. Maximum charging speed, useful when you need to charge the battery as quickly as possible after a deep discharge. This is the default value. Option 3, Only solar. Exclusively from solar, the grid is never used for charging under any circumstances. If you want complete independence from grid charging, this is your option. But keep in mind, if there is no sun for several days in a row, the battery may fully discharge. Option 4, Solar Residual. What remains after covering the load goes toward charging. That is, the inverter first powers everything connected, and whatever is left from solar generation is directed into the battery. The grid is not involved in charging at all. A mode for maximum self-consumption. For most home systems I recommend solar first, that's option 1. Solar takes priority, but if there's none, the grid will help charge the battery overnight. F203, F204, and F207, Charge and Protection Voltages. These three items are only available with battery type USE. If you have AGM, Flooded, or lithium with BMS communication, the inverter sets these values automatically and you simply won't see them in the menu. But if you're on USE, these are critically important parameters. F203, Full Charge Voltage, or Bulk Charging Voltage. This is the voltage to which the inverter charges the battery in CCCV mode. Range from 48 to 62 volts. For 48-volt AGM batteries the standard value is 56.4 volts. For flooded, 58.4 volts. These values are set automatically when the corresponding type is selected, but if you're on USE, enter them manually. Now here's an important detail for those connecting lithium without BMS communication via USE. Say you have a LiFePO4 battery built yourself, and the BMS on it limits the maximum voltage to 54.4 volts. What do you set in F203? Not 54.4, but a bit lower. For example, 53.9 volts. A half-volt buffer between the inverter setting and the BMS threshold is a buffer that prevents the BMS from triggering and disconnecting the battery at the most critical moment of charging. F204, Float Voltage. After the battery reaches the full charge voltage, the inverter doesn't disconnect but reduces the voltage to the float level and holds the battery in that state. For 48-volt systems, float is typically around 54 volts. This allows the battery to remain charged without overcharging. F207, Minimum Load Disconnect Voltage. At what voltage the inverter disconnects the load to protect the battery from deep discharge. Default is 42 volts. Range from 40 to 54 volts. For lithium without BMS communication there is an important rule here. Your disconnect threshold in the inverter must be at least 2 volts above the BMS protection threshold. Why? Because the inverter must disconnect the load first, before the BMS protection kicks in. If the BMS disconnects at 48 volts, set 50 volts in the inverter. Then the sequence will be correct. The inverter disconnects the load at 50, the BMS never reaches its protection threshold and never triggers as an emergency. F205 and F206, Switching Thresholds in SBU mode. These two items are directly linked to the SBU mode from the F1 menu. If you selected SUB or ZEC there, these items are less relevant. But if it's SBU, read carefully. F205, Grid Connection Threshold. At what battery voltage the inverter switches from battery to grid? Default is 46 volts. Simply put, the inverter is in SBU mode, discharging the battery. The battery gradually drains. As soon as the voltage drops to 46 volts, the inverter says, "Stop," and switches to the grid. The battery stops discharging, and the grid starts powering the load. This value can be adjusted to your situation. If you want more energy from the battery and are willing to discharge it deeper, lower the threshold. Say, to 44 volts. If you want to protect the battery and switch to the grid earlier, raise it to 48 volts. But there is a hard rule: this value must always be greater than F207, the minimum disconnect voltage, by at least 1 volt. The logic is simple: the grid must connect before the battery reaches its absolute minimum. If the grid connection threshold equals or is lower than the disconnect threshold, the system will not correctly execute the protection. F206, threshold for returning to battery. After the grid has charged the battery, under what condition does the inverter switch back to battery? There are usually two options here: battery fully charged, only after a full charge to the CV voltage. This is the recommended value, you get maximum reserves before discharging again. Or a specific voltage, for example, 52 volts. Then the inverter switches back as soon as the battery reaches that level, without waiting for a full charge. F208 and F209, charge currents. Two very practical items where you'll need some math, but it's simple. F208, maximum total charge current. This is the combined current from solar and grid together. Range from 10 to 120 amps. Default is 60 amps. How do you pick the right value? For lead-acid batteries there is a simple rule: the maximum charge current must not exceed 20% of the battery capacity. Battery capacity 100 amp hours, maximum 20 amps. 200 amp hours, maximum 40 amps. 400 amp hours, maximum 80 amps. Exceeding this value won't charge the battery faster, but will accelerate degradation. For LiFePO4 lithium batteries the current thresholds are much higher, they can handle 50 and even 100% of capacity. But it's better to check the documentation for your specific battery. F209, maximum charge current from grid only. From 2 to 80 amps. Default is 30 amps. Here it's important to consider your electrical infrastructure. Look at this: you have an input circuit breaker of, say, 32 amps. Current house load is 15 amps. That leaves 17 amps. So for grid charging it's safe to set 10 to 15 amps, with a margin so the breaker doesn't trip during brief consumption spikes. And one more important limitation: F208 cannot be less than F209. The total maximum current cannot be less than the current of one of its components. This is logical, but people often forget it when configuring. F210, F211, F212, F213, and F214, night charge timer. This group of 5 items is similar to the timer we covered in the F1 menu. There, the timer switched the operating mode of the entire system. Here, only the battery charge mode. The classic scenario looks like this. During the day your main charge mode is solar first. There's sun, the battery charges from it. The grid is not used for charging. But at night, say from 11 p.m. to 7 a.m., your utility provider offers a reduced nighttime rate. This is exactly where the timer comes in. F210, which charge mode to activate during the set time window? If this is set to OFF, the timer is not active at all. F211 and F212, hour and minutes for the start of night charging. For example, 2300 hours, 00 minutes. F213 and F214, hour and minutes for the end. For example, 700 hours, 00 minutes. Set F210 to solar and utility, start time 2300, end time 0700, and the inverter will automatically switch to grid charging mode at night at the cheap rate. At 7 in the morning it returns to solar first. By the start of the solar day the battery will be fully charged, and you paid for that at the night rate. I'll repeat the same note as with the F1 timers, all of this runs off the real-time clock. First configure the exact time in the F3 menu. Without that, timers won't work correctly. F215, CV stage duration. This item is also only available with battery type USE. It sets the maximum duration of the CV stage during charging, that is, how long the inverter holds a constant voltage after reaching the full charge level. The default is automatically, the inverter determines the duration itself based on how the battery behaves. For the vast majority of batteries this is the correct behavior, and there is no need to change it. A manual value from 5 to 900 minutes, only if you have a specific battery with precisely known characteristics and you know how long it needs for the CV stage. F216, F217, F218, F219, F220, and F221, battery equalization. 6 consecutive items, and all of them are about equalization. First let me explain what this is, and then we'll go through each item. Equalization is a special elevated charge mode used exclusively for flooded wet cell lead-acid batteries. During long-term operation, individual cells of the battery may develop uneven electrolyte density distribution and plate sulfation. Equalization is an elevated charge at elevated voltage for a limited duration that levels out these imbalances. And here is the most important warning in the entire video: never enable equalization for AGM or gel batteries. Never. The elevated voltage during equalization is destructive to them. It causes gas release inside the sealed casing, swelling, and irreversible damage. Only for flooded wet cell batteries. F216, equalization on, off. Disable by default, enable to activate. F217, equalization voltage. From 48 to 64 volts. Default is 58.4 volts for 48 volt systems. F218, duration of one equalization cycle. From 0 to 900 minutes. Default is 60 minutes. F219, maximum timeout. From 0 to 900 minutes. Default is 120 minutes. If equalization has not completed within this time, the inverter forces it to stop. F220, interval between equalizations. From 1 to 90 days. Default is 30 days. So once a month the inverter automatically performs the procedure. F221, immediate activation. Enable launches equalization right now, without waiting for the schedule. F222 and F223, lithium battery activation. These two items cover a specific but important situation. There are cases when a lithium battery after prolonged storage or after a deep discharge falls asleep, its BMS enters a protection mode and stops responding to signals. From the outside this looks like, you connect the battery, the inverter doesn't detect it or shows an error. F222, manual activation. Select active, and the inverter sends an activation pulse to wake up the BMS. This is a one-time action. F223, automatic activation on startup. With the auto setting, if the battery is not detected at system startup, the inverter will attempt activation on its own without your involvement. After changing this item, an inverter restart is required. F224, F225, and F226, SOC-based control. Now recall items F205, F206, and F207, the ones where we configured switching thresholds in volts. These three items are their equivalent, but instead of volts they use SOC percentages, state of charge. Why two different methods? Because different battery types suit different approaches. For lead-acid batteries, voltage is a reasonable indicator of charge level, though not ideal, as it depends on temperature and load. For lithium batteries with BMS communication, SOC is a much more accurate and convenient indicator. The BMS calculates the charge itself and transmits the exact percentage to the inverter. F224, at what SOC to connect the grid in SBU mode? From 10 to 50%, default is 50. Meaning by default, as soon as the battery discharges to 50%, the grid activates. For most scenarios, 50% is very conservative. You can lower it to 20 to 30% to use the battery more and the grid less. F225, at what SOC to return to battery after grid charging? From 60 to 100%, default is 95. I recommend leaving it at 95, there's no need to wait for 100%, the final stage of charging is very slow. F226, absolute minimum SOC for load disconnect. From 3 to 30%, default is 20. The equivalent of F207, but in percentages. At 20% the inverter disconnects the load to protect the battery from deep discharge. If you have a Pylontech lithium battery or another with BMS communication, control via SOC. It's more accurate and convenient for monitoring. F227, maximum discharge current. This item limits the maximum current at which the inverter can discharge the battery. Option OFF means no limits at all. Or a specific value from 50 to 500 amps. When the set value is exceeded, the inverter stops the battery discharge and switches to the grid or goes into standby. When is this needed? If your battery has a strict maximum discharge current limit, for example, some lithium systems limit discharge to 100 amps. Set 100 here, and the inverter will never exceed that value. If your battery has no such limits, leave it OFF. F228, lithium battery activation duration. This is an extended item not found in the standard manual. It only appears in versions with extended firmware, confirmed by the manufacturer's technical support. It is related to what we covered in F222 and F223, activating a sleeping BMS. There we enable activation, and here we set how many seconds the inverter delivers the activation pulse. Range from 6 to 300 seconds. Default is 6 seconds, that's the value displayed on the screen when you first open it. For most LiFePO4 lithium batteries, 6 seconds is sufficient. Increasing this only makes sense if the standard pulse doesn't help, for example, after a very deep discharge or after prolonged storage in the cold. If you have lead-acid AGM or flooded batteries, this item has no effect on you whatsoever. Leave it at 6 and don't think about it. Well, 28 items, done. Let's wrap up with 2 concrete scenarios. First scenario, lead-acid AGM batteries, say 2 batteries of 100 Ah in series, 200 Ah total at 48 volts. F201 set to AGM, F202, solar first, solar charging takes priority. F208, maximum total charge current 40 amps, that's 20% of 200 Ah. F209, grid charge current 10 to 15 amps depending on your supply. F205, grid connection threshold in SBU mode is 46 volts. We leave equalization alone, AGM doesn't support it. Second scenario, Pylontech US2000 lithium battery, for example 2 units in parallel, total capacity 180 Ah. F201 set to Li2. Everything else, voltages, algorithms, thresholds, the BMS transmits to the inverter automatically. Your only task is to configure the SoC, F224, 20% for grid connection, F225, 95% for returning to battery, F226, 10% absolute minimum. In the next video, the final part of the series, the F3 and F4 menus. Real-time clock and service functions. It's quick, but important, especially if you configured timers in F1 and F2. See you there.